Okay, so this is problem number 2 from the assignment, the pendulum problem. I'll read it. A pendulum hung from a ceiling makes a complete back and forth swing each 6 seconds. See figure 838K. As the pendulum swings, its distance d in centimeters from one wall of the room depends on the time t in seconds since it was set in motion. At t equals 1.3, d is at its maximum of 110 centimeters from the wall. The lower bound of d is 50 centimeters. Assume that d is a sinusoidal function of t. A, write an equation expressing d as a function of t. Right? So, to write the equation, well, we actually need to know the amplitude. We have a maximum, they tell us, a maximum distance from the wall of 110 centimeters. And we have a minimum distance of 50 centimeters. So the amplitude, in this case, it'll be the same as our value of A, is 110 minus 50 divided by 2. And that happens to be 30. 30 what? 30 centimeters. I don't need the units here. I just want to write the equation. Okay. I also need the value of the midline or sinusoidal axis. Equals some value of d, and this value of d is the average of the maximum and the minimum. So 110 plus 50 divided by 2, and that happens to be 80. Right. Next is we know the period. We need to find the value of b, but knowing the period, that's not too difficult. The period, they tell us, is 6 seconds. It's right here. So, period is 6 seconds. Okay, that means the value of b is 2 pi divided by the period. 6 seconds, or simplified to 5/3. Now, in the phase shift, if we use cosine, the value of c is the value of the independent variable, in this case time, at which the function is at its maximum, and it happens to be at 1.3 seconds. Okay, so I have A, B, B, C, and D, and I can write the distance. So this is a different D, not the D from our sinusoidal function. D is of distance. So the distance from the wall, that depends on the time, is amplitude 30 cosine of the value of b, 5/3 times t minus 1.3, the value of c, plus b. Okay, d is in centimeters and t is in seconds. Okay, let's see part B. Write an equation for the derivative function. Okay. The derivative of the d prime of t is the derivative of 30 times cosine of something. So that is 30 times the derivative of cosine, which is negative sine of 5/3 t minus 1.3 times the derivative of the inside. The derivative of the inside is simply 5/3. So that's the derivative of this part, plus the derivative of 80, and that, of course, is 0. Now it's a matter of simplifying this. Notice that the 30 and the thirds can simplify to just 10, and we'll move the pi to the front. So that would be that's a long tone. That would be 30 divided by 3 is 10. 10 times pi. And then we have negative sine of 5/3 times t minus 1.3. Okay, this is the derivative. Oops. Let's see what else they ask. They're asking, how fast is the pendulum moving when t is 5 and when t is 11? And how do you explain the relationship between these two answers? Okay, so let's find out. How fast is it moving? That's the speed. Okay, let's find the velocity at time 5. So it's just a matter of putting, substituting 5 here, and basically I will simply put it on a calculator. I get negative 10 pi sine of 5/3 times 5 minus 1.3. Right, I get 21.021. Now first, and there's more decimals, so I'm accurate to 3 decimal places. What are the units of this? See, D is in centimeters and time is in seconds, but this is the derivative. So, so this is not D. This one is in centimeters per second. It's a rate of change. Now let's see, D of 11. It's the same thing. I'm just going to substitute 11 instead of 3. And I can do that actually quite quickly. I get exactly the same value. Centimeters per second. Now, it says here, how do you explain the relationship between these two answers? The two answers are the same. How is it that they're the same? Well, the difference in the times is 6 seconds, and that's our period. So they are the same because they're exactly one cycle apart or one period apart. They're exactly one cycle or one period apart. Let's see, part D. At time 20, is the pendulum moving toward the wall or away from it? Explain. Okay, so first of all, in order to find that out, I need to find the derivative at time 20. So just substitute 20 for the derivative. Well, it's not too difficult. I'll just put it here in the calculator, 20. And I get a value of negative 21.021 centimeters per second. Now, the fact that this is negative means that the rate of change of the distance from the wall is negative at that moment. So, since d prime of 20 is negative, the pendulum is really reducing its distance from the wall. So if it's reducing the distance from the wall, it's moving towards it, towards the wall. Okay, part E. What is the fastest the pendulum swings? Where is the pendulum when it is swinging its fastest? Okay, so what is the fastest? I have here the function for the velocity. So I just need to see when or what is the value of the maximum value of this function? Now, sine goes from -1 to 1. I don't care what's inside. I know the maximum of sine is 1, the minimum is -1, but it's being multiplied by a negative number. So in order to find the total maximum, I need the greatest in the negatives, or the least of these numbers, which is -1. So what is the fastest the pendulum swings? -10 pi times -1 is +10 pi. +10, which is approximately 31.416. These are centimeters per second. Now, where is the pendulum when it is swinging its fastest? Okay, now the pendulum swings its fastest when the sine is -1. Okay, so basically I'm saying sine of pi thirds t minus 1.3 must equal -1. Now, if I do sine inverse, I will have that the angle or the argument of the sine, which is pi thirds times t minus 1.3, must equal -1, happens at negative pi halves. Now it's a matter of solving for t to find when is it. The question is where is the pendulum. But with the time, we're going to find the position. Okay, I can divide by pi on both sides, it cancels. I'm going to multiply times 3 on the other side. So this is t minus 1.3 equals 3 divided by 2, which is 1.5. And therefore t is 2.8 seconds. At time, 2.8 seconds. Now I'm going to go back and substitute 2.8 seconds in the formula for position, which we can't see on screen right now. So it's this one. Okay, so if I put the distance at time 2.8 seconds, that is substitute here using cosine 2.8 instead of the t, we'll find out. Let's do this. Okay, so let's see, 30. Plus 80. Okay, it happens to be 80. That means that this part turned out to be 0. So if it's 80, that also means that it's exactly in the middle because it's the midline, the half distance between the maximum and the minimum. So it's when the pendulum is at its lowest. But the question was the position. So I will simply say at a distance of 80 centimeters. At 80 centimeters from the wall. Okay, and the last one, which is F. What is the first positive value of t at which the pendulum is swinging at 0 centimeters per second? Where is the pendulum at this time? Okay, so we know, I think this is easiest just to analyze from over here. Okay, we know that at time 1.3, it's at its maximum value. That is around here, right? And that it takes 6 full seconds to do a complete round, a complete cycle. Okay, so if it's at 1.3, then it's over here. 3 seconds later, it will be at the minimum. And 3 seconds after that, it will be again at the maximum. Okay, so let's take it back. 1.3 seconds, it's at a maximum. If I subtract 3 seconds, it'll be at the minimum. Okay, at the minimum, 1.3 minus 3 is negative 1.7. Okay, so it didn't start there. It started somewhere over here between the maximum and the minimum. Now, when is it velocity 0? Well, that's when it changes from going away from the wall to towards the wall, or when it changes from towards the wall to away from the wall. Okay, so the first time it does this, or one time it does this, is at 1.3 seconds because it is at its maximum. And 3 seconds before, wait, that's negative. It would be at a minimum, but we don't have negative time. So the first time it happens is at time 1.3. And the question also asks, where is it? Oh, it's at the maximum distance from the wall. So let's just write that down. T equals 1.3 seconds. And it is at 110 centimeters, which is the maximum from the wall. And that's it for this problem.